Good morning. I was hoping we would be in class today because today's topic can be a little bit difficult to wrap your arms around. And that is a function family that you have probably not heard of called the logarithmic function family. And actually what logarithmic functions are inverses of the exponential functions that we just learned about. So I'm going to try and help you understand that a little bit. So remember, right here, y equals b to the x, that's an exponential function. So remember, to find the inverse, you'd exchange the x and the y, and then you would solve. So you would get x equals b to the y. Now that is a logarithmic function right there. All right, so when it's written y equals b to the x, that's exponential, and x equals b to the y is logarithmic. However, our next task, as you recall, is to get y by itself. And we do not have a way yet to get y by itself. So I'm going to introduce a new concept to you, which is how we get y by itself. So here's what that is, and it's a logarithm. So this equation right here, b to the y equals x, can be rewritten as this. And this is, the way you say this is log base b of x equals y. And that is what a logarithm is. That is how it is defined. And I'm going to keep referring to the definition of the logarithm. And what that means for you is that you just need to keep in mind that, let me get the pointer going here, this is the same as this. And a lot of times, if we have a logarithmic function, if we rewrite it this way, we can help ourselves do things that we need to do with it. And sometimes if it's written this way, we can rewrite it this way. So we're going to go back and forth a little bit, but I just need you to know a logarithmic function is the inverse of an exponential function. The first thing we're going to do here is we're going to practice using our definition of a logarithm and going back and forth between writing a logarithm in these two different ways. And it's important for us to be able to go back and forth between the two. And I think that one of those things that helps us do this is actually to label the parts of the equation or expression that we're given. So you can see here I've got 100 equals 10 squared, and that is super obvious. 10 squared equals 100. So if you go over here and look at our definition, you are going to see that this is given to us in the exponential form. So right here, if it's written like this, this is what we call the exponential form of a logarithmic function. And if it's written like this, this is logarithmic form. Okay, so here's what we've got in exponential form. This is our x, this is our b, and the little 2 is our y. So now that we've labeled everything, what we're going to do is rewrite this in logarithmic form. So it starts out with y equals, and y is 2. So we're going to write 2 equals. Now we've got log base b, and the b here is 10, so log base 10 of x, which is 100. Simple. Okay. Let's go on to the next one. So again, this is written in the form x equals b to the y. 81 is 3 to the 4th. We know that. So this is x, this is b, and the little 4 is the y. So let's go ahead and write this in logarithmic form. This is y equals log base b of x, so y is 4, equals log base b of, which is 3 of x, which is 81. Now here's what's cool. You now know log base 3 of 81 happens to equal 4. The next thing we're going to do is evaluate a logarithm. So what we want to do, for example, let's look at example B. It's probably the easiest one on the page. Log base 5 of 125, and we want to know what that happens to equal. And the way that we have to do this is we need to change this from being written in logarithmic form to being written in exponential form. And then we can solve the exponential equation, which is something new that we're going to learn right now. So here's the thing. The logarithm, log base b of x equals, this will be y. And so we're trying to find y. We know that this position is our x, and the little 5 is the b. So what we're going to do is take our various numbers and we're going to rewrite them, because here's your definition. We need to rewrite them in the form x equals b to the y. So here's what I'm going to have. I'm going to have, switch colors, 125 equals 5 to the y power. Now, I need to know what the y power is. What you are going to do when you go about solving an exponential equation, which is what this is you need to get the same, both sides to be written as exponents with the same base. So if we look over on the right-hand side, we have a base of 5. Can we rewrite 125 as 5 to another power? And we can. It's 5 to the third power. And this is also why in chapter 6 you needed to memorize all those wonderful root facts. So 5 to the third power equals 5 to the y power. Now, if you have both sides of your equation written with the same base, then the exponents must be equal. So we now know then that 3 must equal y. So if we go back up to our original equation, we were trying to find y, and y is 3. Okay, let's try one that's maybe a little bit more difficult. We'll go to A, example A. So the first thing I want to do is I want to label my parts, and I'm going to actually run out of room up here, I'm pretty sure. But the 8 is the B. This is the x, and this is going to equal y. Sorry, hard to write really little. And we're going to rewrite this in the form x equals b to the y. So we're going to rewrite this as 32 equals 8 to the y power. Now, once again, we need to try and get both sides of the equation to be written with the same base, and we do have a base of 8. However, I can't write 32 as 8 to a power, so that's not going to work. I need to go with another plan, and so my next plan is, can I write the 32 and the 8 both as a power of the same number? And we can, because 32 happens to be 2 to the 5th power, and 8 is 2 to the 3rd power. So what I'm going to do, I'm out of room over here, so I'm going to come down to here, and I'm going to write 32 as 2 to the 5th power. And next, I'm going to write 8 as 2 to the 3rd power, and then that is raised to the y power. I'm going to use my laws of exponent. That gives me 2 to the 5th power equals 2 to the 3y power. And now what you'll notice is I do have the same base on both sides of the equation, and so this exponent must equal this exponent. And what that allows me to do is write an equation that 5 must equal 3y, divide both sides by 3, and y is going to equal 5/3. So I can go back up here to my expression, and I find out that log base 8 of 32 equals 5/3. Okay, let's do one more together, because I know these can be kind of tricky. So again, let's go to example C, and the 64, that is our base. 1 over 32, that is our x, and this is going to equal whatever our y value is. So now put this in the form x equals b to the y. So I have 1 over 32 equals 64 to the y power. Okay, and this is going to work out a lot like example A. 64 I can't write as a power of 32 or 1 over 32, but here's what I am going to do with it. 32 and 64 are both powers of 2. So here's what I'm going to do. I'm going to write 1 over 2 to the 5th, because 2 to the 5th is 32. I'm going to rewrite 64 as 2 to the 6th, and I know it's 2 to the 6th because 32 is 2 to the 5th, and if I multiply another 2 times 32, I get 64. All right, so there to the y power. Now, I still have the problem of the fraction on the left-hand side, but if you recall my laws of exponents, I can rewrite this as 2 to the negative 5th power, and this side is 2 to the 6y power. All right, and now if you notice, I do have the same base on both sides. So therefore, this exponent must equal this exponent. I'm going to go over here and I'm going to write negative 5 equals 6y. Divide both sides by 6, and y equals negative 5, 6. So I can fill in my answer with negative 5, 6.